In our lesson today, we're going to look at applications of trigonometry, and we studied trig last time and looked at our trig ratios. And so we're going to answer some word problems that involve trig. In the first one, it says that Mike looks out the attic window of his home, which is 22 feet above the ground. And so we can see in our picture here, there's where he is in his attic, and this distance right here, from here to here, is 22 feet. Okay. Now, at an angle of elevation of 35 degrees, he sees a bird sitting at the top of a very large high-rise apartment building down the street. How tall is the high-rise apartment building if the two buildings are 75 feet apart? Okay, so we can see the bird is up here on top of the apartment building, and we're told that if we have this angle of elevation here from where he is in the attic up to the bird, that's going to be 35 degrees. And we're also told that from his house to the apartment building, this is a distance of 75 feet, okay? And so what we want to do is see if we can figure out, well, what's this height right here from this part just above the trees to the top of the building? And then we can combine that with the 22 feet that we would have right here to figure out the total height of the apartment building. So let's call this distance x. Okay, and so based on where this angle is, x is opposite, and 75, the distance between the two, is the adjacent side. Opposite and adjacent is going to be tangent. So to help us answer this question, we're going to do the tangent of 35 degrees. And that's going to be equal to the opposite, which was x, over 75, which was the adjacent side. And so if we multiply both sides by 75, okay, those are going to simplify. All right, x is going to equal 75 times the tangent of 35. Okay, so we can go ahead and punch that into our calculator. 75 times tangent of 35. And that's going to give us 52 and 51556537, which is approximately 53 feet. 53 feet. Okay, so this distance from here, the top, down to where we see this dotted line right here, this is a distance of about 53 feet. And we also knew that from here to the ground was 22 feet, so if we can combine them, 53 plus 22, we get an answer of 75. And so that must be the height of the apartment building. The apartment building is 75 feet high. In example 2, we're told that Cody is building a doghouse for his dog Fido. The house is 3 feet wide, 3 feet tall, and 4 feet deep, and the roof makes a 58-degree angle with the horizontal, which we can see right here in the picture. The special shingles for the roof come in 9 square foot bundles at $15.95 per bundle. Find the price of shingling the roof when the shingles must be purchased in complete bundles. And the roof, again, consists of 2 rectangles. So there's one rectangle here, and we can envision that the other one would be over here. Express your answer to the nearest penny. So what we're going to have to do here is figure out the dimensions of these rectangular sides, and then that's going to help us figure out how many square feet of shingles we need, and that's going to help us determine how many bundles we're going to need. Okay, so we know right here that this is a 58-degree angle, and we were told that it's 3 feet wide. Okay, and what we're going to want to try to do is figure out what is the length of this side, okay, which is also going to be the length of this side found right here. And to help me do that, I see I've got a triangle here, and I'm going to go ahead and draw an altitude. All right, that's going to drop it straight down, and this altitude is actually going to split this 3-foot segment in half. So from here to here is 1.5 feet. So I can go ahead and draw that in as 1.5 feet. Okay, and I'm looking for this measurement right here, which I'll call x. Okay, so the side that I know, this piece right here, is the adjacent side to the 58-degree angle, and this is the hypotenuse. Adjacent and hypotenuse is going to have to be cosine. So I'm going to use the cosine function, cosine of 58 degrees. And that's going to be equal to the adjacent side right here of 1.5 feet over the hypotenuse, which is unknown. That's my x. Okay, so I would multiply both sides by x, And then I'm going to have to divide each side by the cosine of 58. So x is going to equal 1 5/10 divided by the cosine of 58. And again, I can go ahead and I can punch that into my calculator. And reading off all those digits, I get 2 and 830619872. Okay, and so that's the length of this hypotenuse right here, which again is the same as this measurement found right here. Okay, so now I know what this length right here is, and I know this right here on my rectangle is 4 feet. Okay, so to find the dimensions of that rectangle, I'm going to have to take that number and multiply it by 4. Okay, so if I do 2 and 830619872 and multiply it by 4, that'll tell me the area of one of the rectangles, but since there's 2, I'm going to multiply this by 2. Okay, so I'm going to punch all this into my calculator, and when I do that, I get 22 and 6449, excuse me, 5898. Okay, that's the square footage of both of the rectangular pieces combined. Okay, now I know that each bundle contains 9 square feet of shingles. So what I'm going to do, I'm going to take this entire area, the 22 and 64495898, and I'm going to divide it by the 9 square feet that are in each bundle, and this will tell me how many bundles I should buy. So when I punch this into my calculator, I divide by 9, I get 2.5161065553. Which means 2 bundles isn't going to be enough. I need a little bit more than that, so I'm going to have to end up buying 3 bundles of shingles. Okay? And so now if I want to figure out what the price is going to be, well, I'm just going to multiply. It's $15.95 times the 3 bundles, which is going to give us a total cost of $47.85. And that's how much we're going to have to pay for our shingles. In example 3, we're told that from the top of the Eiffel Tower, a jogger is spotted heading toward the tower. At 2 p.m., the angle of depression of the jogger at point A was measured to be 37 degrees. Okay. 4 minutes later, at point B, when measured again, the angle of depression had increased by 35 degrees. Find the average speed of the jogger to the nearest foot per minute. So the first thing we're going to have to do is find out how far the jogger traveled first. So what I'm going to do, I'm going to figure out what's this distance from when the jogger is at point A to the tower. I'm going to call that X. And I'm going to figure out, well, when he's at point B, how far away is he still from the tower? And I'm going to call this distance Y. If I know the measure of X and I figure out what this value is for Y, I can subtract them to figure out the total distance that the jogger traveled in 4 minutes. And then I can do a quick division to figure out the speed per minute. So let's go ahead and do that. All right. The first thing I'm going to do, I'm going to figure out what is this measurement from A to the tower. And to help me with that, I'm going to be using the fact that we had an angle of depression at point A of 37 degrees. Okay, well, if this is 37 degrees, and I know that this is a right angle here, that's 37, which means that the rest of this angle here must be 90 minus 37, which is going to be 53 degrees. Okay, so this is a 53 degree angle here. X is opposite of that. And I also know that the tower is 986 feet tall, and that's going to be the adjacent side. So again, I've got opposite and adjacent, so I'm going to use tangent. So I'm going to do tangent of 53 equals the opposite side, which is X, what I'm looking for, over the adjacent side, which was 986, which is the height of the tower. So I'm going to multiply both sides by 986. So to get X, it's going to be 986 times the tangent of 53. And I'll go ahead and punch that into my calculator. And when I do that, I get 1,308 and 466,194. Okay, so that again is the number of feet from A to the tower. Now I know that at point B, okay, it had increased, the angle of elevation had increased 35 degrees. So I want to see if I can figure out how far is the jogger still away from the tower when they're at point B. So again, I know that this now is the full angle of elevation, and that's going to end up being 72 degrees, which means that this angle in here must be 18 degrees. And so that's what I'm going to use to help me figure out this distance for y. This is my angle 18 degrees, y is opposite, and again 986 is the adjacent side, so we're once again going to use tangent. Tangent of 18 degrees this time is going to equal the opposite, which I'm calling y, over 986, which again was the height of the tower. Multiply both sides by the 986, so y is going to equal 986 times the tangent of 18. And reading off my calculator, I see that's going to be 320 and 3708205 feet. Okay, so I need to figure out, well, how far did the jogger go in 4 minutes? So I'm going to take the total distance, which was x, and I'm going to subtract off this distance, y, to figure out the amount traveled. So let's subtract these two numbers, 1308.466194 minus 320.3708205, and that gives me 988 and 0.95375 feet. Okay, that's how many feet the jogger traveled in 4 minutes. Okay, they started here at A, 4 minutes later they were at point B. They want to know the speed of the jogger in feet per minute. So I'm going to take my distance that I've traveled, and I'm going to divide it by 4 because that's how many feet they traveled in 4 minutes. So if we do 988.0953735 and divide it by 4, that's going to give me 247.0238434. And to the nearest foot per minute, this is going to be then approximately 247 feet per minute that the jogger is traveling. In example 6, we're told that ABCD is a rectangle that has a perimeter of 34, and they want us to find to the nearest degree the measure of angle E. And so we're going to first look at rectangle ABCD. They've labeled BC as 12, so we know that AD is also 12. Okay, and the entire perimeter is 34. Okay, well, 12 plus 12 is 24. That means that these two sides added together must equal 10. And if you divide 10 by 2, that means that each of these sides is going to be equal to 5. And that helps us get the measure of angle E, which is right down here, which I'll label as theta. If I look at this angle right here, I know the opposite side is 5 and the hypotenuse is 11, so I can use the sine in order to figure out the measure of the angle. Sine of theta is going to equal the opposite of 5 over the hypotenuse of 11. So to get the measure of this angle theta, I'm going to do the inverse sine. Theta equals the inverse sine of the ratio 5/11. And so if I punch that into my calculator, then my theta is going to equal 27 and 0.3569179. And it said to the nearest degree, so we're going to say that this is approximately a 27 degree angle.